So this lesson is going to be about gas pressure and then some revision questions. If you're in set 1, then you're going to be doing Boyle's Law next lesson. But if you're not, then we're going to be doing a test next lesson. So just make sure that you're ready and prepared for that. So gas pressure then. I'm going to start with some golf balls in a celebrations tub. Now that might seem a bit of an odd thing to do, but if we're thinking about particles and molecules and atoms in a gas, we can't really imagine them very well. So it's easier if we imagine, if we can just think about something that's a lot bigger, because the same rules pretty much will apply when we kind of scale it down. So I've got 6 golf balls in a celebrations tub. I'm going to put the lid on. And when I kind of shake it, the golf balls hit the wall of the celebrations tub. Okay, they hit the wall of the container. And that will mean that there's a force on the wall of the container. And we know from year 9, before we started the GCSE actually, that a force in a certain area gives a pressure. And so there's a pressure on the walls of this container when I shake the box. I can change that pressure. I can change that pressure by shaking the box more slowly. If I shake the box more slowly, the golf balls are moving more slowly. They've got less kinetic energy. So when they're moving around, they're going to collide with the walls of the container more slowly. And so the force is going to be a bit less. The pressure on the walls of the container is going to be less. So when the particles are moving around more slowly, that means that they're going the temperature is lower. Temperature is a measurement of how fast particles move, or a measurement of the average speed that the particles move. So temperature is a measurement of average kinetic energy of particles. Actually, is a proper way of saying it, because in real world situations, not all of the particles have got the same mass. So let's just go with average kinetic energy of molecules is what we measure when we're measuring temperature. And if that kinetic energy is lower, then the temperature is lower. And if the kinetic energy is larger, so let's throw this around. So much so that the lid popped off, actually. That means that the pressure is larger. The pressure was so large that the container couldn't even hold all of the gas in the container. And it went, and the gas came out, or the golf balls came out. There's another way that I can change the pressure of the gas. And that would be if I made the container smaller, then these golf balls are going to hit the container more often, and so the pressure is going to be larger there as well for the same speed that I shake it, or the same temperature, if you like. The pressure is going to be larger if the container is smaller, because the golf ball is going to hit the container more often, or maybe the pressure might make the container bigger. The pressure will be lower because the golf balls are going to hit the container less often. An important point to note here, though, is that I know that in chemistry you've done rates of reaction. And in rates of reaction, you're talking about particles or molecules or atoms have to collide with an activation energy for a chemical reaction to happen. We're not talking about that here at all. There's no such thing as an unsuccessful collision between a particle and the wall of the container. Every collision between a particle and the wall of the container means there's going to be a force, means there's going to be pressure. So just separate rates of reaction from chemistry with gas pressure from physics. Actually, gas pressure is chemistry as well, a little bit, but we're not talking about successful and unsuccessful collisions when we're talking about gas pressure, just to let you know.